Hello everyone, so welcome back to the good stuff that we've been doing. In this video we're going to from this equation y equals to e to the 3x a plus bx plus cs squared, we are going to form a differential equation corresponding to this equation. And the way you mostly form this differential equation is that you mostly differentiate. Let's say the simplest example is y equals to e to the x. Let's say y equals to e to the x. So for this kind of equation, you just take derivative, you get y prime, or if you prefer dy dx being equal to e to the x, because when you take derivative of e to the x, you get e to the x. So in this case you get dy dx being equals to y, because e to the x is y. So this equation now is what we call the differential equation. So it is the equation we get from eliminating a constant from an equation. So corresponding to this differential equation, we are going to eliminate a, b and c. Once all that is done, then we have formed a differential equation. Let's proceed. Now we take derivative, we get dy dx. This is equals to, now how do we take derivative here? E to the 3x, derivative of e to the 3x is just 3e to the 3x, so this is 3e to the 3x, and we're multiplying by a plus bx plus cx squared. Then the next case, we're going to take derivative of a plus bx plus cs squared. That will be b, so we are going to have e to the 3x multiplying by b plus 2cx. So let me demarcate it. So what we can do next is to just notice that here e to the 3x a plus bx plus cs squared, this is what we have here. So we're going to replace this with y to simplify things a bit. So this is dy dx is equals to 3y, I believe, plus e to the 3x, then we then have b plus 2cx. Now what do we do next here? Obviously we have to take derivative again, because here we have succeeded in eliminating a, but we still have to deal with b and c. So usually, even if you don't know what to do next in differential equation, mostly take derivative. Like the next step usually most of the time is by taking derivative. So here, once we take our derivative, what do we have? Notice that for this case here, for the first case, we just have d squared y over dx squared. Now here we have 3, this is dy dx, because if we take derivative of y, we get dy dx. What about e to the 3x? Well, obviously we have e to the 3x, then b plus 2cx. What about derivative of b plus 2cx? That is just 2c. So plus 2c e to the 3x. So let's just rule it. And notice that here we have, just like we eliminated this, we have to eliminate this as follows: this b plus 2cx, because here notice that e to the 3x b plus 2cx is equals to, first of all, we have the squared y over dx squared is equals to, now we have 3 dy dx, but the b plus 2cx, when you move this to this part, you have this is equals to, this is plus dy dx still yet minus 3y, then we see we then have plus 2c e to the 3x. Now here's what we did there. Okay, let's say that, okay, this, what we take derivative of e to the 3x, we're going to have 3 e to the 3x, so 3 should be here. So that means that we should have a 3 multiplying all this. Okay, let me group it this way. So yeah, that is correct. This is what we did here. From this first line, this is the second line, let me see, from line 2, we took derivative, we got d squared y over dx squared. That will be equals to then 3 dy dx, because derivative of y is dy dx, plus, now we took derivative of e to the 3x, that will be 3 e to the 3x b plus cx, then we take the derivative of b plus 2cx. That will give me 2c. Then we multiply by e to the 3x. But this expression alone is equals to dy dx minus 3y. So this will be 3 times dy dx minus 3y. And then we can obviously simplify a bit to give us d squared y over dx squared will be equals to 3. This will be 3 plus 3, that is 6. So 6 dy dx. Then we have minus 9y plus 2c e to the 3x. So I will just go to the next section, and then we'll start. Let's see. We stopped at d squared y over dx squared will be equals to let me see. That would be 6 dy dx minus 9y. So that would be 6 times dy dx minus 9y plus I believe 2c to the 3x. Let me confirm. So that is 2c to the 3x. Now what do we have next here? How do we proceed? Well, just like before, we take derivative again. So taking derivative, or let me say taking the third derivative, that will give us that here this will be d cubed y over ds cubed. So that will be d cubed y over ds cubed. Now what do we have next? This is equals to 6d squared y over dx squared minus 9 dy dx, obviously. What about here? This will be plus 2. This is 6. That will be plus 6c e to the 3x. So that will be 6c e to the 3x. Now, what do we do next here? Obviously, we have to eliminate this. And notice that 2c to the 3x will be just so we have d cubed y over dx cubed is equals to 6d squared y over dx squared. Now minus 9 dy dx. So what do we do with this now? Notice that 2c to the 3x is just d squared y, so we have plus 3. Now instead of the notice that this is 3 times 2, so we just the 2c to the 3x, we assume that this is 3 times 2c e to the 3x. So this 2c to the 3x alone here, which is here, will be equals to d squared y over dx squared minus 6 dy dx, then plus 9, I believe 9y. Yeah. So we have d cubed y over dx cubed, but that would be equal to, that is that this is 3 times this is 3 times 6 plus 3, that would be 9. So this will be 9 d squared y over dx squared. This is 3 times 6 is negative 18. So negative 18 minus 9, that would be negative 27, that is minus 27 dy dx. So what do we have next? That is plus 27y. So usually we write this as this. This will be d cubed y over dx cubed minus 9d squared y over dx squared plus 27 dy dx minus 27y equals to 0. So this is an equation that does not involve neither a, b or c. So we have eliminated the constants from the equation. Let's go back. This a, b and c have been eliminated, and this is the resulting differential equation corresponding to that function here. So this is the resulting differential equation. So thank you for watching, and please do have a nice day. Bye.